Now, decide if f of x is continuous at the specified value. By the way, polynomials, which is what we deal with primarily, is continuous everywhere. It's never not continuous. And you think about what causes discontinuities. Asymptotes are division by zero. Wholes are divisions by zero that factor out. Jumps don't come naturally. They come from piecewise functions. So how do I go about showing that something is discontinuous? Well, what you want to do, and I pulled that paper out when I really wanted this one, I need to show three things. That f of c is defined, that the limit as x approaches c of f of x exists, and that the limit as x approaches c of f of x is f of c. Now, if I'm dealing with a polynomial, I say polynomials are continuous everywhere. It's continuous by definition, and actually by theorem from college algebra. But let's do the grunt work. So A, I need to say, is f of c defined? Well, how do I know if f of c is defined? Plug it in, plug it in. Number in, number out, it's defined, right? Number in, problem, I got to take a look at the issue. Number in, problem, division by zero, could be a vertical asymptote. It could not, may not be continuous there. But if I look at f of 0, and I like f of 0, this is 0 cubed minus 2 times 0 squared plus 0 minus 5. If I'm looking at f of 0, and that's a little small, if I'm looking at f of 0, it's just everything drops out except that it's negative 5. So I'd say, yes, it is, check. B. Does the limit as x approaches 0 of f of x exist? Well, how do I do the limit as x approaches 0? What do I need to do? What do I need to do to take the limit? Plug it in, plug it in. Number in, number out. It exists, right? So we know that the limit as x approaches 0 of f of x equals negative 5. Check. That's what I mean. This is kind of, in a sense, stupid, right? And then finally, is the limit as x approaches 0 of f of x equal to, question mark, f of 0. So in this particular instance, the limit as x approaches 0 of f of x equals what? Negative 5. And f of 0 equals, are they the same? So is this thing continuous? Yeah. That's done on polynomials. Personally, I would say from college algebra, by theorem, polynomials are continuous. All polynomials are continuous. What's wrong with this guy? Well, what's wrong with him? What's his possibilities? I have a vertical asymptote at x equal 2, don't I? Well, the first thing I want to do is A, is f of c defined? Well, f of 2 equals 2 times 2 plus 1 over 3 times 2 minus 6, which is 5 over 0. And what do I know 5 over 0 is? So what do I know? It fails. A. So is f of x continuous?
No.
F of x is not continuous. And we know why is it not continuous. At x equal 2, what's happening?
Vertical asymptote.
We have a vertical asymptote. We have VA. So we don't have to do any more. Once we know if it's failed one of the three, it's done. So I failed the first one. Don't have to do the other two. Only has to fail one of the three. All three must be true. Okay, here we go. Now, what do I know about x squared minus 3? It's a polynomial. What do I know about polynomials? So this guy's continuous. And what do I know about x squared minus 1 over x plus 1? It has something happening at x equal negative 1. What's my break point? Negative 1. What's the point I'm interested in? Negative 1. So I have to start out with A is f of negative 1 defined. Well, f of negative 1 is part of x squared minus 3, is it not? Because this guy is greater than or equal to. So at x equal negative 1, I'm going to have negative 1 squared minus 3, which is 1 minus 3, which is negative 2. So does y exist at negative 1? Yes. B. Does the limit as x approaches c of, or x approaches negative 1 of f of x exist? Well, in order to do that, since I'm on either side of negative 1, what am I going to have to do? I'm going to have to take the limit in two pieces, aren't I? To the left of negative 1 and to the right of negative 1. So I'm going to take the limit as x approaches negative 1. I'm going to do the easy one first of the right, and this I have to use x squared minus 3. This I just plug it in, plug it in. This is negative 1 squared minus 3, which is negative 2. So it exists from the right. Now the question is, what about the limit as x approaches negative 1 from the left? Now if I'm coming in from the left, I'm using this top function. So this says this is going to be x squared minus 1 over x plus 1. And if I plug it in, this is negative 1 squared minus 1 over negative 1 plus 1, which is 0 over 0. And what does 0 over 0 tell me?
Algebra.
Algebra. So using algebra, I know I have x squared minus 1 over x plus 1, which is x minus 1 times x plus 1 over x plus 1. X plus 1's reduce out. Now I need to take the limit as x approaches negative 1 from the left, and this time I'm just using x minus 1, which is minus 1, which is minus 2. So what just happened? The limit from the left equals the limit from the right. So does the limit exist? Yeah. What's the definition of the limit existing? Limit from the left equals the limit from the right. So that means I don't have a jump discontinuity. Weird wacko. Okay, so yes, it's true. C. Does the limit as x approaches c, or x approaches negative 1, of f of x equal f of negative 1? Well, part B gives me that the limit as x approaches negative 1 is what? Negative 2. And part A, f of negative 1 is? So does it satisfy part C?
Yes.
Yeah. Is this guy continuous?
Yes.
Yeah. What happened? See, if I think about what's going on, at x equal negative 1, y equals negative 2. That's what this is saying. And if I'm coming in from the left, it is y equals, I need to find it, x minus 1. So it says this guy's coming in, and there's a hole here. What did the other guy do? What did the other guy do? He filled in the hole. And that was what? He looks something like that. Is that continuous? Yeah. Weird. But see, piecewise functions are weird anyway. They're just weird creatures.